A classic calculation that we find in general chemistry is the finding of a molecular weight of an unknown using colligative properties. So this typically shows up all the time on exams. Also, this calculation is used in general chemistry labs, so it's very common to have a lab that utilizes this fact to find the molecular weight of an unknown. So you can use any of the colligative properties that we've been talking about, things like boiling point elevation, freezing point depression, or osmotic pressure. But typically the calculations involve boiling point elevation and freezing point depression. So I have not seen too many examples where we use osmotic pressure, but it is possible. So you can apply sort of the techniques that we're looking at here. So we're going to be focusing on an example of these two. We're going to be looking at the boiling point elevation, but you can see once we understand the steps, you could apply this easily to a freezing point depression. So here what we need is a solution. And what we're doing is we're taking a certain number of grams of our unknown. So we know how many grams of the unknown we're putting in, and we have to assume that the I value is equal to 1. So we don't know what the unknown molecule is, but we know that it's not a salt. So we're going to assume that the I value is equal to 1. And then we know how many grams of our solvent. In this case, our solvent is phenol. Solvent doesn't really matter that much. Right now, we just need to know exactly how many grams of our solvent that we have. Also, we need to know what the boiling point for our solvent is when it's not in a solution. So this is our pure solvent. We need to know the boiling point elevation constant for phenol, which is given here. And then we need to know the boiling point of a solution. So it's very easy to find a boiling point of a solution. When you mix the two things together, you find the boiling point of it. And overall, what we want to do is find the molar mass or molecular weight of our unknown here. So the first thing that you want to do in this calculation is find our change in the boiling point of our solvent. So we're looking at the change in the boiling point. That's going to be the temperature of our solution, or the boiling point temperature of our solution minus the boiling point temperature of our pure solvent. So we were given the boiling point of the solution here. We are given the boiling point of our solvent here. Overall, we find our change in our boiling point to be 0.818 degrees C. Then we're going to look at our boiling point elevation calculation. So here we've just found our change in our boiling point. We know what I is. We assume that's 1 kb was given. And overall what we want to find is the molality of the solution that we've made here. So when we dissolved our unknown into our solvent, what is the molality of that solution? So here we're looking for little m. We calculated our change in our boiling point. I, we assumed was 1, and Kb was given. So when we do this calculation, we get our solution is 0.05 molal. So now that we have molal, when we look at the units on it, it's moles of solute divided by kilograms of solvent. And moles of solute is something that we want to find. A molecular weight is grams per mole, and we've already found the grams. Now we want to find the number of moles. So the next thing that we want to do is find how many moles of solute. In order to do that, we need the molal, where we just calculated it here, and we need to know how many kilograms of solvent. Well, that was given. We weighed that out at the very beginning of the experiment. So taking this equation, solving it for moles of solute, that's the molal of our solution, well, we found it right here, times the kilograms of our solvent. So remember, in the original question, it was our solvent phenol was given as 100 grams, so we need to convert that to kilograms. That's one of the tricky parts of molality, is it's mole of solute divided by kilograms of solvent. So we needed to convert gram to kilogram here. When we multiply these two values together, we find in our solution we have 0.005 moles of our unknown. So now we have enough information to find our molar mass or molecular weight of our unknown. So molar mass is grams per mole. Well, we know how many grams of our unknown we put into the solution. That was given in the original question. We weigh that out and we put it into our solvent. Then we found out how many moles of our unknown were dissolved inside of our solution. We did that by looking at the colligative properties. By that I mean our change in our boiling point. So we were able to calculate the number of moles of unknown inside of our solution here. And to find the molar mass, it's just grams divided by mole. And in this case, our molar mass of our unknown was 128 grams per mole.